Hello again. I just wanted to make a quick video on a few quantum numbers practice problems. So we'll do a couple of about four questions, but to review, let's go over our quantum numbers quickly. So our first quantum number is a principal quantum number. Its symbol is n, and this first quantum number can have integers, whole number integers of 1, 2, 3, 4, 5, and so on, and they refer to the rows in the periodic table. So 1, 2, 3, 4, 5, and so on. And they also refer to the distance that an electron is away from the nucleus of an atom, and the amount of energy it has as well. Okay, moving on. Our secondary quantum number, referring to the subshells, is symbolized by the letter L. Now, these L can have a range of numbers that relates to n, and that range is 0 to n minus 1. These have the values, or can have the values, 0, 1, 2, and 3, where 0 represents the s orbit, 1 represents the p orbital, which is really that dumbbell shape, 2 represents the d orbital, and 3 is the f orbital. Okay. Next, our third quantum number refers to the orientation of an electron, referring directly to the suborbital shape SPDF. So that is symbolized by M, cursive L, and that has a range of negative L to positive L. Right, so as an example, change color here, as an example, if we have L is equal to, let's say, 1, therefore ML is going to have a range of negative 1 to positive 1, and all whole number integers including 0. So that range will be negative 1, 0, and positive 1. These represent orientations of the P shape, rather a dumbbell shape, which is referred to by 1, right? We reviewed this last time, but this is X, this would be X, this would be Y, and this would be Z. Okay, our fourth quantum number. Again, if you need to pause, go back to your notes, rethink things, look at a periodic table. It's probably a good idea you do that if you think you need to. Okay, our fourth quantum number is our magnetic spin number. And that only has two possibilities, either a positive or a negative half. An electron moving clockwise or counterclockwise. We'll get to it also being described as a spin up or spin down, right? Going back to our periodic table, actually go to one I have posted here. Um, within a shape or within a suborbital, our first half of electrons are your positives, positive half spins. Second half are your negative half spins. So in our s orbital, we have one electron spinning up, rather positive half, and one electron spinning down, or negative half. Under p, we have the first 3 electrons with a positive half spin, and the last 3 with a negative half spin. Right? It's a great little periodic table here. It really summarizes these quantum numbers. D has the same. So first 5 are positive half, last 5 are negative half, and these are their orientations right there. Our F block here, same thing, except we range from -3 to +3. The first half are positive half spins, the last half, our last 7 are your negative half. Okay, so that's our quick review of the 4 quantum numbers. Now, our first problem. All right, so we'll start with first question. Which set of 4 quantum numbers is not possible here? So this implies there should just be one, but you want to check over all of them just to be sure. So if n is equal to 4, that's 1, 2, 3, 4. We're looking at this row. So n is equal to 4 is possible. Good. L is equal to 2, so that refers to the shape. Remember, 0 is S, 1 is P, 2 is D, and 3 is F. Okay, so L is 2 means that it is the d orbital. So is that possible? Let's see. At n is equal to 4, 1, 2, 3, 4, we have, do we have a d orbital? Let's see. This is 4s. This is this whole part here, that is 3D. All of this here, that is 3D. 4D actually occurs below in the fifth row, but it really is 4D. So is 4D possible? Yes, 4D is possible. So that number is correct. Now, orientation is -1. Well, that's possible because if we have a 2 value here, then we know the range is going to be from -2 to +2, and this -1 falls within that range, so that's also possible, right? Now, positive half. Well, yes, the first half, the first 5 electrons here are going to be positive half, and the next 5 are going to be negative half, so that number is also possible. So A is correct, which means it's not the right answer. B, n is equal to 3. Let me just erase erase that. Okay, back to my pen. Good. N is equal to 3. 1, 2, 3. That's this row. Okay, that is of course possible. L is 0, which means it is the s orbital in the third row, so it can be one of these electrons. So that's possible. That's possible. M, referring to the orientation, 0. Well, there is only one orientation here. It is 0, right? We know that these two are related because our ML values, or orientation, is a range of 0, well, -0 to +0, which really just means 0. So that means this is also possible. S, could S be -half? Well, yes, it can be, because this row, rather this column here under S, is going to be positive, so we can draw this, positive half, and this column is going to be negative half. So what we actually see is we can pinpoint exactly what electron this is referring to. It's referring to magnesium's electron. So yes, that number, those numbers, are actually possible, right? Which means B is not the correct answer. C, let's try that one. N is equal to 2. Yep, that's the second row. It's possible. L is equal to 2. All right, second row with a D shape. Let's see. We have 2S possible here, and moving along we have 2P, but that's it, because the next shape, the D that it's referring to, this D here, D doesn't actually begin until the third energy level, right? And we know that 3D starts right here. There's no such thing as 2D, which means this is wrong, making C our correct answer, right? Um, Next, we have n is equal to 5. 1, 2, 3, 4, 5 right here. Of course, that's possible. L is equal to 3, which refers to your F block. Yep, that's possible. Um, Although your F block actually begins on the 6th row, it's actually two principal quantum numbers lower. So here we have 4F, and here we have 5F. We'll practice this some more, but those are your F blocks. So is 5F possible? Yes, it is. M is equal to, or ML is equal to -2. Well, this ranges from, because of L is equal to not -3, this ranges from -3 to +3. Is -2 within that range? Yes, it is. So this is also possible. I didn't check these out, so that's right. That's right. That's right. Now, last number, -half. Well, yes, anything on this end is going to be your -half. Rather, this end here under 5F is going to be -half. So yes, this is also possible, which means the only incorrect one is C. Question 1 is done. Now, if you're wondering where I got these questions from, it's your homework. It's all posted. Okay. Last few questions. That one took a little bit longer because it was more like 4 questions in one. Okay. Next, here we're going to it's asking us to write the 4 quantum numbers which describe the location of the highest energy electron of the following. So it really wants us to write the 4 quantum numbers for electron number 7. Now I've included this great periodic table here. I posted in our lesson as well. And I just want to erase this. Okay. So I'll refer back to that slide. So if n is equal to 7, rather 7th electron, we want all quantum numbers for that 7th electron. Now that's going to be, I will have to go here. 1, 2, 3, 4, 5. Sorry, I counted wrong. 1, 2, hydrogen, helium, 3, 4, 5, 6, 7, nitrogen. So nitrogen is 1, there was a 2 here, 2, 3, 4, 5, 6, 7. Okay, it's referring to this electron here. Let's highlight that, or let's circle it. 3, 4, 5, 6, 7, right here. This electron, this is where nitrogen is. So quantum numbers for nitrogen's electron. All right, well, N refers to the energy level. We know that it's in the second row, so N is equal to 2. 2. Next, shape. It's in the p orbital, which means 1. ML refers to the orientation. All right, orientation. We know that it ranges from, if p is 1, that means it must range from -1 to +1. It turns out this 7th electron falls under the +1 orientation, which we know to be Z orientation. Okay, it's not asking us for which one, X, Y, Z. It's asking us for numbers. So we're going to write +1. Again, hope I didn't confuse you there. -1, 0, +1, +1. Okay, last number refers to spin. It is in the first half, right, of this p block. So it's going to be positive. So positive half. And we're done. Next, nickel, 28. A little harder because nickel is actually found in your transition elements or in your D block. So nickel right here, right? We count in 1, 2, 3, 4, 5, 6, 7, 8. It's 8 electrons into the 3D block. Let's count where that is. 1, 2, 3, 4, 5, 6, 7, 8 right here. So this is nickel. Okay. Nickel is in the 3D block, 0 orientation, negative half spin. Basically answered all of that there, but let's put it all down. So N is in the third energy level. L is the referring to the shape because it's D, it's going to be 2. ML is our orientation. Let's see where that was. ML orientation is 0. It can go from -2, -1, 0, +1, +2. Repeat that. -2, -0. Sorry, -2, -1, 0. It's in the 0 orientation. That particular 1 electron. So 0 orientation. Last number, MS. Is it on the first half of the suborbital or second half? It's on the second half, so it's going to be a negative half. Okay. Next, the fourth electron in carbon, right? So carbon is right here, right? It's 4 electrons in on the second, 4 elements in on the second energy level. So 1, 2, 3, 4. So right before nitrogen is where we find our last question, carbon. This is in the second energy level. It's in the L is equal to 1 or P shape orbital, and it has an orientation of 0 and a positive half spin. Right, again, answered all of that, but let's write that down. So N is equal to 2, L referring to the p orbital, which is 1, ML refers to the orientation of the 4th electron, that's 1, 2, 3, 4, that's a 0, which actually we know to be the Y orientation, right? Last, MS is in the first or second half. It is in the first half, so it's positive half. Positive half. And you're done. Hopefully that helped. We'll meet again online to answer any questions.